if the central limit theorem holds true, then we can describe the sampling distribution. So the sampling distribution, or that's the distribution of sample means, will be normally distributed if the central limit theorem holds true. The mean of the sampling distribution will be equal to the population mean. And we're going to denote the mean of the sampling distribution by this mu with this little subscript of x bar here, which is right here. And we're going to say the mean of the sample means is equal to the population mean. And then 3, we can also talk about the standard deviation of the sampling distribution. It's going to be approximately equal to the square root of the population variance divided by the sample size. So the standard deviation of the sampling distribution is called the standard error, and it's going to be denoted by the sigma with this little subscript of x bar here. Okay? And sigma of x bar, so the standard error is going to be equal to the variance divided by n, and then the square root of that. Or you can write it this way. These are equal to each other, which is be the standard deviation. So this would be the standard deviation, just sigma, divided by the square root of n. So these two are equal to each other, okay? So either one will work. It just depends if you already have the variance or if you have the standard deviation. And so if you notice in this formula for the standard error, if the sample size n increases, right, our sigma x bar, which is the standard error, will decrease. Because we're going to divide by a bigger number as our n increases, and that makes the overall number less. That makes our standard error less. And so statisticians say that you can estimate the standard deviation of the sampling distribution by taking this formula, either one, either the square root of the variance divided by n or the standard deviation divided by the square root of n. Now I'm going to go over an example of describing the sampling distribution. So say we have a normal distribution of test scores across America, and they have a mean of 80 and a variance of 9. We plan to randomly sample 16 Americans. Describe the sampling distribution. So 1, we know the sampling distribution is normally distributed. Why? Because the population distribution of test scores is already normally distributed. And it doesn't matter that our sample size of 16 is less than 30. So if we have a normal distribution, it doesn't matter about the sample size. So our original population distribution was normally distributed, and also our sampling distribution is normally distributed because it's not going to change shape on us. And then we also know that our mean of our sample means, or our mean of our sampling distribution, is equal to the population mean. And we know from this little blurb up here that the population mean was 80. Okay? So this first sentence is talking about the population. It's not talking about the sampling distribution. It's talking about the population. Okay? So this is the population mean of 80. But we know that the mean of sampling distribution is equal to the population mean. And we know the population mean is 80 from our little blurb up here. And number 3, we can find the this standard error. And we know what the variance is. Our population variance is 9. So we're going to put 9 here. And then we know that we're going to take 16 Americans, so our sample size n is 16, and we take the square root of that, that's going to equal 3/4. Okay? So we're going to have a standard error of 3/4. So we described the shape of the sampling distribution, its mean, and its standard deviation, which is called the standard error. Now here's another example of describing the sampling distribution. So a skewed distribution of test scores across Asia has a mean of 100 and a standard deviation of 12. So this first sentence, again, we're talking about the population, right? You would think a population, would be all Asians in Asia. And so a lot of people, we're never going to be able to survey them all. So we're going to plan to take a random sample of 36 Asians, okay? So say somehow we already know these things about the population. We know that the population is skewed, and it has a population mean of 100 and a population standard deviation of 12. So this first sentence here is about the population, okay? So we know that the sampling distribution is normally distributed. Why? Because our n equals 36. So it's above that kind of rule of thumb of 30 for the central limit theorem. Okay, so that means that we can use the central limit theorem here. It didn't matter that we started out with a skewed population distribution because our n is at least 30. And then we know that our mean of our sampling distribution is equal to the population mean, which was 100. And then we're going to calculate the standard error, and we're going to use the other formula that I had because we already have the standard deviation instead of the variance. So we're going to take the standard deviation of 12 and divide it by the square root of 36, which is our sample size. So we're going to have 12 divided by the square root of 36, and so that's going to be 12 divided by 6, which equals 2. So we describe three things here. When we describe the sampling distribution, we describe the shape. It's going to be normally distributed. We're describing the mean. It's going to be a mean of 100, and we're going to describe the standard error, which is going to be 2.